Sounds good.
All right. Can Zoom hear me? Yes. Silence is yes.
We'll watch chat. One person on Zoom, actually.
You know. Yeah. Welcome to AI security. This is the best week, obviously. I'm not biased at all. But yeah, this is going to be like a really chill intro to like what AI security means, because like it can mean a couple different things. And also like it's not that common outside of like AI security cases. So yeah, like I don't really have any challenges. Like they take forever to build, and also like they're hard to solve. You don't have some previous knowledge of AI, probably. Well, no, that's a lie because there are automated tools. But it's just good to get it. So that's what we're doing today. It's gonna be really chill. Next slide, please. Cool. Announcements. We have lots of them. First one, the bar crawl is tonight. ACM's running it. It's going to be a good time. A lot of us are coming out there. You have to be 19, but you don't have to be over 21, and you don't have to drink. I'm sober. I don't drink. So if you're like, I don't want to like go so far because I'm going to be drunk, I will be there and we can party together. Okay. Boiler CTF is this weekend. We're playing it. It's going to be a good time. It will also probably take the place of the Sunday meeting, just because like we're going to be CTFing instead. Come out, play, chill out with us. It'll be fun. SIGPwny next Thursday. We're not going to be here next Thursday because like 16 of us are going to SIGPwny. So for whoever's not going to SIGPwny, if you want to like come on Thursday and like hang out anyways, feel free. And you can run your own. Meetings and have a good time. And we'll Zoom link or something. I don't know. But yeah, we won't be here. And teachers, fill out the Google form that Pete sends out. Thank you, Pete. For ordering t-shirts. They will be $10, I think, and they look sick. Excellent. All right, painting flag. I don't know if there's a meeting challenge because I didn't make it. But once there is, it's the meeting flag. And also kind of the best. It's a very applicable XKCD. Obviously, XKCD applies to everything. And it's just like AI models aren't super great at being good at things outside of their training set. So like a lot of AI models will be like, yeah, we got like 60 million% accuracy. And it's like, yeah, you do on your test set, on your training set, but like if you put it in the real world, it fails instantly. And that's not very secure. Hello, friends. Next slide. All right, overview. So AI security as a field in general, there are two meanings to AI security. And people kind of use them, and people use the term AI security for both, so you kind of have to figure out what they're actually talking about in order to actually, understand like which branch you're interested in. So the first one is using AI for security purposes. So this looks like a lot of what SIGPwny does, just like automated, right? So it'd be like, like network scanning, but AI, looking for malware, but AI. So it's a lot of like, can we train AI to look at things for us and like monitor security for us, right? So that's one branch of AI security. The other branch is the stuff that I focus on, right? And that's the security of AI itself. So looking at models, looking at vulnerabilities, and trying to figure out, like, is this secure? Can we use this in the real world? Are there things that may cause this to fail? And if so, how will it fail? And what is the consequences of it failing? Both are super awesome fields, but AI security can be in either one. People kind of use them interchangeably. And I think that they should either clarify themselves or use different words because they're not very similar, right? Like exploring the security of AI is a lot of like looking into AI itself, and the other one is like, can you apply AI to security? They're kind of next slide. All right, so the first thing we're going to go into is AI for security. Next slide. So this looks a lot like AI for malware or like AI for network scanning, like I was talking about earlier. So like using AI to find malware and kind of shut down execution before it executes. So scanning code before it executes or like stuff you download and being like, hey, is this going to be malware? Let's run it for an AI and find out. And or AI for network monitoring, so like scanning packets to be like, is this is this like safe stuff or is someone trying to DDoS my system? Like some of that's kind of obvious, like the DDoS, like if you have like 7 million packets being sent at once, probably. But I don't know, maybe it could. So like that's something that people are trying to use AI to kind of like do real-time monitoring 24/7 with confidence. And there's also like everything is like an AI applied to it these days. I think you can probably find some paper somewhere that someone's writing. So just like anything that requires either human foresight or monitoring, people are going to try and apply AI to it because it's way easier to have a model that does your work for you instead of like having people to like sit there and watch things 24/7. Next one. There are good things and bad things about doing this, obviously, because AI can, in the places you can be kind of good things. There is the potential to find undiscovered malware and patches. So malware that like no one's kind of identified as like something new that's like say there's like a new Trojan that hasn't really been identified as a being problematic yet. And some like AI scanning for malware might have the ability to shut it down before people really like give it a name and identify it as a problem. So before it does any damage, right? And that's a good thing because it means that like undiscovered bugs that may not like someone may not have like pointed them out as like malware may also not work just because we're scanning for it already. Discovered bugs before they can be exploited, so like running codes or something that checks for bugs. Like this is kind of vague because this isn't my area of specialty. I'm not the one doing like AI for bug detection, but I know they exist. So if you are interested, it's definitely something to check out. So like running your code through something to like check for bugs that may or not even bugs, which like code that doesn't work as intended and may not do well. And continuous monitoring without continuous human involvement. It's been a lot of what I've seen personally. Is like, can AI take the place of humans for like grunt work, right? So instead of someone monitoring your packets or like someone monitoring logs or stuff that looks sus, like put all your network packets to an AI and what the AI tells you is problematic, right? And it'll be like a much smaller subset than your logs or just looking at packets themselves, which I hope no one's doing 24/7. But there are also bad things, right? With AI, there's the potential to misclassify, like say something like goes undetected, right? Something that humans may identify as being malware or something, but because it's an AI that fails, what happens when it fails? Does it wreck your system? What happens then, right? So there is that potential, and like AI accuracy rates are often like people say they're higher than humans, but they're still not anywhere near perfect, right? Like 80% can be considered perfect. What happens with the other 20%, right? It's misclassifying like 1/5 of the time. And that's on data seen already. You're telling it, like you're telling it this is how you classify. And then it gets like 80% accuracy. What happens? Also, AI is a black box. If it makes decisions, you don't know what's going on, right? Like you just see like infinite output, and you can kind of correlate the two, but you never know what decision calculus it's making. So that's not really great if you're trying to like make actual decisions based on an AI's help. And does its accuracy generalize to the real world, right? Like you're given a training data set or like a data set to train on. It's like here's malware and this is malware, this piece of code is malware, this is right? But how does that generalize to the real world? Does malware always look like your training data set? How big is your data set? All these questions about AI are when they have real world consequences, they matter. So that's kind of a con when it comes to actually using the system. All right, this is the other half. So the security of AI, right? So this is how to look into AI systems and make sure they're actually secure or robust. Next. Cool. A lot of security of AI stuff deals with how to make models behave incorrectly on purpose, right? So you're trying to trigger a misclassification, you're trying to trigger something to happen that isn't within the purview of the AI should be, but it's intentional, right? So it's not like an AI like messing up or like getting something wrong. This is something you can trigger every time in ways that can massively mess up an AI model with introduction. The keyword you want to look for here that's in a lot of current AI So something I like to mention is that like super small differences in input can completely change the output for certain sets of models that aren't trained right, or even like most models that are trained in computer vision are vulnerable in this way, right? Where it's like if you change the small, if you're changing it by like a certain like tiny amount, it'll completely misclassify. It looks the same to us. So like if you're manually looking at like input to a system, it'll look fine. But because they are like adversarial input, it'll completely misclassify that and get up. Next slide. There are many good uses to studying like adversarial systems or looking at AI systems from a security perspective. The first is privacy preservation. So like adversarial input does have good uses, right? Like if you're say someone is like, say someone is using facial recognition in ways that are harmful. Knowing about adversarial input and using things that could be adversarial can trick facial recognition into not recognizing it. So some people have started initiatives to, whatever like selfies you upload to like Facebook or whatever, run them through like something that'll make them adversarial input before you upload. It'll look the same. So you'll get all the likes and stuff. But anyone trying to use your face for things that you may not really enjoy, it'll mess with the model because it is subtly adversarial. Vulnerability detection. Finding where the AI fits is useful, right? So now we know that adversarial systems for computer vision exist or text models exist, and we know roughly what they are, so we can try to mitigate them, right? So research is currently actively being done to how to mitigate them, but knowing that they exist means that you can use them. Explainability. Knowing what a model sees and knowing that a model is acting more like a human is a good thing, right? So like I said earlier, with like tiny changes in input, you're still like that's not something that human eye can see. But at a certain point, you can train a model to ignore those tiny changes in input. And then you know that the model is roughly looking more at things that you would expect, right? So edges, colors, stuff that a human sees when they're like classifying things. And robustness. This is how a model performs in the real world on data that it hasn't seen when it's been trained, right? So, for example, if you're training AI for one example I like to use a lot is self-driving cars, right? If you're training AI for self-driving cars, you're giving it, data like roads or whatever. How will it perform on a road it hasn't seen? How will it perform if a stop sign disappears? Or if someone like graffiti's a stop sign? You want us to be able to perform all those conditions, and that's called robustness. And obviously, like with normal training methods, there really isn't that much robustness because it hasn't seen those conditions and it'll fail in those conditions. So how do we train AI models that are robust to those inputs? And because robustness has real life consequences. Harmful uses. Attacking production systems is the main one. So y'all might have seen papers about how, again, self-driving cars, if you put teeth in certain positions on stop signs, it won't read them as stop signs. Or if you change a stop sign so that it's like halfway, it won't think it's a stop sign. Humans think it's a stop sign most of the time. But in AI world, and obviously that has real life consequences. What if the car crashes, right? So not a great use, but it exists, and that's something that you have to kind of defend against. And it's what a lot of the good users try to mitigate. Next. All right, this is not one of the two branches of AI security, but it's very closely related, so I wanted to talk about it. This is privacy within AI. So how do we train AI in a way that is respectful of user data and respectful of the privacy of users, right? Because that's important, especially when you're training on user data. Next. So there are kind of three different sides that I've seen into this, and that I'm referencing off like some papers that I wrote here that I can link each if you want to learn more about this specifically. But PPML is a huge field, so do your own research as well. I've done some parts of this, but there's a lot of others. So the first is the data collection side. How do you select proper data sets? There are ethical problems that people are starting to point out in some of the most common data sets. Where it's like, hey, these labels aren't correct. Hey, these people with faces didn't And that's a problem because you're now using that data to train AI models, but it's not data that you collect ethically or data that you should. So that's obviously not very privacy preserving. So you want to fix that. And that, there are papers that deal with, hey, here's a new data set, right? So, this is a side of research. How do we collect data? Data processing. Can we make the data that we train on more valuable? So this looks like adding noise to cases, right? Even if they were given with permission, what if because AI can't have a problem with parity, right? Or just directly reproduces something that it's trained on. This is a problem. This is a problem sometimes generative materials ants, right? So I don't know if you all saw the dolly down suburbs been having. But generative models can just generate their training data, right? That's the stuff they've seen before. So can we do something to our training data so that if it does happen to generate something that it's seen before, it's not just giving you a picture of someone else's face that they may not really want to have, right? But yeah, looking at the way we process data and making sure it is ethical and privacy preserving. The last thing is the architecture side. How can we design models in ways that are privacy preserving and are respectful of user data, right? So one that I work with really closely right now is model federation, which is normally when you're training AI, it's centralized, right? You pull data from users and you put it in this big data set, and then you train on that data set. And a model can see pretty much the entire data set at one time. And you do all sorts of math stuff. So it's normalized and centered at mean zero, all this stuff, right? Where it's an ideal data set for you to train on. But that obviously means that you have this large bank of user data that may not be the best to keep, right? Especially if you're training on sensitive data. So model federation trains on centralized data. So the way I like to put it is if you're training on phone data, right? You want to train on, how do people math on. But you don't necessarily want that data in your servers. So what you do is you have a centralized model, so a model that you keep on your servers, and you send that in, and you send copies of it to everyone's phone, train on their data in their phone, and then send the weights back. There are problems with this. People have been figuring out, hey, if we mess with the data on our phone, can we figure out what the model is doing? Can we figure out what other users' input is? And obviously these are other parts of AI security. But on the whole, if you can make federation more secure, then that means that your data never leaves your device, right? And that's a good thing. It means no one's keeping your data for longer than you have it stay. It means that your data never leaves your possession. Another thing is model unlearning. Say someone no longer wants their data to be part of an AI. What happens then? With GDPR, there's the right to be forgotten, right? How do we follow that with AI that is inherently learning on your data? Can we teach it to forget? How do we teach it to forget? Are there ways that you can design things that AI systems so that there is a capability of forgetting someone who doesn't want to be in a data? There is a ton of research on this. I have a friend doing research on it actually, and I think it's really interesting, right? Because that is inherently privacy preserving to say no. Career paths. Where do we go from here? We can talk about how it went from a SIGPwny setting, but how do I get more involved in this after I leave university? There are three main things that I can think of. The main thing is research. A lot of this is it isn't really in production right now because it's a very, very new field, right? 2021 is papers are coming out all the time. This field is maybe a few years old at most. But there are two main sides to that research, right? So the first side is industrial research. A lot of good research comes out because companies have this interest, right? I think Google was one of the first ones to make federated learning a big deal because they were yeah, maybe our AI should be more private. So doing that research with a company or over the company's labs is a good idea. There's also academia, right? There are big labs. One of them is here on campus. Y'all probably heard me talk about it before, but there are AI security classes here, and there are AI security labs here, and there are people doing research here. If you are, I don't have that many connections, but come talk to me. We'll figure it out together. And then there's AI engineering and AI products, right? So material, like how to make models more robust, how does it directly translate into models performing well on real world data. That's something every AI next. Cool. All right, we're done. That's the most of me talking. It's questions time. Ask me anything. I can't guarantee the answer because I am but one person, but I will try my best.
What classes are available to take next semester?
Oh man. So there are two that I can think of off the top of my head. The first one is I believe it's still 498, it might not be. It's called Trustworthy Machine Learning. It's taught by Tom Sao, I believe.
It's a 498, so.
Okay, it is still 498. It's called 498 TML. And that one is more theoretical as far as I've seen than your professor teach it. But if you like theory and you are interested in AI theory, it covers a lot of really good ground on what all of this means and how to get into it. There's also a 500 level class. Jesus. 562 with Goldie. And it covers a lot of this, I believe, from a slightly more practical standpoint. It is a graduate level class, but I have faith in y'all. And it does require some security knowledge, which is very easily bypassable by being part of this club. So yeah, if you are interested in coffee, I'm in the class next semester, so I'll let y'all know how it goes.
Did you register?
Registration isn't open yet, but I have permission to do it. Because permission for undergrads will do this in late summer.
Okay.
Yeah.
Semester starts.
Yeah. Which is
I'm also good at this.
oh my god, we'll take it together. It'll be great. But yeah, other questions.
You talked about something about uploading stories, like making them adversarial before you upload. Could you elaborate on what is adversarial?
Sure.
Can you repeat the question for Zoom?
Oh yeah. So if I talked about how you can upload photos to social media and make them adversarial. How do you do that? So there are a lot of techniques to make a photo adversarial, but what that means basically is you can take really popular facial recognition models and there are ways to use basically how the model learns against it. And what that does is generate tiny instances of norms, right? That you can add to your picture, and then it's just no longer recognized as a face. Which obviously messes with the system, right? Because it's seeing your face is being added to this data set, but it can't find a face. Or your image is being added to this data set, but it's just wrongly classified according to the model, and it will just mess with the model. So if you're interested in that, I believe there are websites that do it. I don't know if they're public anymore because they may have been taken down. But talk to me about it because I do know how to do this. I do it for research, and I'm happy to teach you. Honestly, yeah. It is also the basic making adversarial images is also. I don't know if y'all remember. There's a challenge called Please Please from the UCCF last year. That was written by me plus friends, including me and the friends. But the basis of that challenge is how do you fool a non-robust model? Most models are non-robust, right? So, making adversarial images can apply to any given model.
What is the process for creating an adversarial image? How do you go about attacking these AI models?
Oh man. Okay, so there are a bunch of really interesting ways. I'll talk about the criticism really quick. This might get a little bit into how AI works, right? So basically when you train AI, I'm going to really quick visual example because I'm not going to get into the details of how it works. AI is a very big optimization problem. We're given a 5D, 60, 20 million graph, and you have to find the lowest point on the graph. That's the math behind AI. That's why you need a lot of calculus in AI or whatever. It's all because AI is trying to training an AI is trying to find that minimum point. And to do that, you're looking at gradients, right? You're you're taking a point, moving it, and seeing where is the largest gradient. How do I get from the highest point to the lowest point the fastest? But with that gradient, you can also move a point up to a worse location, right? So given an image, let's say you have an image that is in like the pig part of your graph, right? So you're given an image and it's in like this part, and it's like, okay, yeah, we're here. It's like a pig. We think it's like this image. You can basically add noise, add very specifically created noise, in order to move it out of the label. This may not make a ton of sense. There's actually a really good article. Okay. There was a write-up of Pony's Please that explains this in probably better detail than I can, just because it has like code examples and like graphs and stuff that I can't link. It won a write-up. It was like the first solve for Pony's Please, and also I think won write-up money. But it's a very good example of how like these images are created and how you can create them because it has the code for solving Pony's Please. So I will share that with you. Okay. Thanks.
You mentioned something about, I mean, AI being black box. Is there, I mean, I know that there's been some research done in like trying to understand how, especially image models, like see.
Right.
And I imagine that has some applications.
Yeah.
Could you talk about that?
Sure. Yeah. So the question was, there has been some research into like AI is the black box, but there has been some research into how image models quote unquote see and how does that affect security. Yeah. So there are ways that you can actually visualize. I guess like there are saliency graphs you can make where it's like this is what an AI model thinks is the most important part of this image, right? And kind of backtrack from there, where it's like, oh yeah, it kind of thinks, like the eye of a face is important to it being a face, right? And like here's where it's looking, here's where it thinks it's supposed to be. And that does have security applications because if you look at a saliency graph and it's all just like random bullshit, it's probably not looking at the right places. But security, like because a lot of adversarial stuff is so minute, saliency graphs and stuff like that may not even like the weights of like saliency graphs may still like say, oh yeah, like the eye is important, right? But if you change a few pixels in the eye, we'll still recognize it as an eye. And that I think delves into a different portion than like vision explainability. But I think the two work hand in hand, where it's like you can use one to make the other. Does that make sense?
Yeah.
Cool. Any other questions? Cool. What's up?
If you could guess, how far is AI out from being like at that point where we're starting to have like really high accuracy stuff, like GPT-3, but like contextually relevant? You think we're like 5 years out before it gets scary, 10 years out before it gets scary? Because it's starting to get scary.
Sure. I mean, I think so. The question was how far do I think AI is from becoming scary? And is that like scary good or like? Well, so the thing is, I think it's a little impossible to predict because AI advances are so fast. Like the field, like in 2014, is so radically. Like I think CNN like barely a thing, and that was a little bit, so it's kind of impossible to predict. So I'm not going to give you like a great answer on this. I'm not really going to give you a number either. I also think a lot of tasks right now are very limited in how, like, it can be good at one very, very specific thing, given a lot of training data and a lot of resources and time, right? Like GPT-3 took like a ton of hours and like a huge data set. So I think that only has a limited amount of relevancy and context. It's like how many tasks can you like find a huge data set for give like a bajillion hours of time? So it'll be interesting to see where it goes. I don't really have an answer, but I think it depends on a lot of things. All right. Any other questions? Cool. I'm gonna call it here. Does Zoom have anything?
Nothing on Zoom.
Cool. All right. I think that's it. I think the next one should be announcements. Or next meeting. We don't really have next meetings because we're we're gonna be playing Boiler CTF and then we're going to SIGPwny. We all want to play Boiler CTF. That'll be fun.
Our next actual thing we may do together may very well be hackers.
Ooh, yes.
So
Keep your eyes peeled.
I could do, we go to see a movie every year. We try renting out the Savoy movie theater and put on the film Hackers. So that'll be fun. We're gonna have to buy it again because I left it up in my apartment or in my county home. So
Very fun.
gonna have to go buy it on Amazon again.
We're single-handedly keeping.
You're
hackers
single-handedly keeping whoever's selling Hackers Blu-ray on Amazon in business. But yeah, that'll be fun. Usually we get food before, so we'll do that and then we'll go to a movie. That'll probably be what, 2 Thursdays from now, 3 Thursdays from now, something like that.
Well, sometimes.
Sometime soon. It's before reading day, so it'll be fun.
Watch the Discord. We'll always
Watch
announce
the
it.
Discord.
Cool. Let's give it up for Anusha. And let's get this meeting flagged up. All right. Thank you, Min. Okay.